You know how a shopping site can instantly show you products that look just like the one you're checking out? Or how a music app serves up a song you've never heard before but you instantly love? Well, the magic behind all that is finding similar items inside these absolutely gigantic databases. Today, we're going to pull back the curtain on a super powerful tool called FAISS, which does exactly that. It literally finds the needle in a billion haystacks. All right, let's dive right in. And to really get a handle on this, we first need to understand the scale of the challenge we're even talking about. It all starts with one simple, kind of overwhelming fact: the data explosion. I mean, think about it. Every single day, we're creating an amount of data that's almost impossible to imagine. You've got all the products listed online, every single image that an AI processes for things like facial recognition, and every sentence that gets analyzed by language models. We're talking about massive, constantly growing mountains of information. So that leads us to the real problem, right? When you have billions of items, and each one of those items has maybe hundreds or even thousands of different features, how in the world do you find the one that's most similar to what you're looking for? And how do you do it in the blink of an eye? That's the multi-billion-dollar question. And the answer for a whole lot of the biggest tech companies on the planet is a library with a pretty simple name: FAISS. So, FAISS stands for Facebook AI Similarity Search, and it's an open-source library that was built by Meta. Its entire job is to do one thing, and do it exceptionally well: search for similar things among what we call dense vectors. The easiest way to think about a vector is like a numerical fingerprint for an item, whether that item is a song, a product, or a picture. And here's what's so wild. The scale that FAISS was designed for, we're not just talking about a few million items here. No, FAISS is built from the ground up to handle datasets with over 1 billion of these complex, high-dimensional fingerprints. It's a truly industrial-strength solution for a planet-sized problem. This diagram shows you exactly how it fits into a system. See, on the left, you have a search query. Let's say it's a piece of text. That text gets converted into one of those numerical vector fingerprints. At the same time, your whole database of text has also been turned into vectors. FAISS is the engine in the middle that takes your query vector and almost instantly finds the most similar vectors from its massive index, giving you back your search results. Okay, so to understand the real genius behind FAISS, we actually need to start with the baseline. The simplest, most straightforward way to do this: a brute force search. This method is called index-flat-L2. Okay, imagine you're in a giant library and you want to find a book that's most similar to the one you're holding. The brute force approach is to literally compare your book to every single other book on every shelf in the entire library, one by one. That's exactly what index-flat-L2 does. It exhaustively compares your query to every single item in the database. Now, why would anyone ever do this? Well, it's got two huge advantages. First, you are absolutely 100% guaranteed to find the perfect match, the true nearest neighbor. There's no guesswork at all. And second, it's incredibly simple to set up and use. You don't need any complex configuration. It sounds perfect, doesn't it? Guaranteed accuracy. So what's the catch? Well, the catch is speed and resources. Let's go back to that library. If your library has 1 billion books, checking every single one is going to take a very, very, very long time and a ton of energy. For huge datasets, this brute force method is just way too slow and memory hungry to be practical. So let's actually walk through what this looks like in practice with some code. It really just breaks down into 5 straightforward steps. So first, you need your data. Let's say our library has 100,000 items. Second, you tell FAISS, hey, I want to build that simple brute force index. Third, you just load all your data into it. Fourth, you bring your search queries, let's say 10 items you're looking for, and you ask the index to find the 5 closest matches for each one. And finally, FAISS gives you back the results. And here it is, the payoff. The search gives you back 2 arrays. That D array tells you the distances, basically how close the matches are. But the I array, that's the real gold. It gives you the exact IDs, the index numbers of the 5 most similar items for each of your queries. You've found your needles in the haystack. So this simple example perfectly sets up the single most important concept you need to grasp when you're working with FAISS, or really any large-scale search system. And that is the trade-off between accuracy and speed. So as you can see, you really have 2 main choices. On one side, you've got index-flat-L2. It guarantees perfect accuracy, but man, it can be slow. But on the other side, this is where the real magic of FAISS is. Instead of checking every book in the library, what if you first organize the library into genres? Now, if you're looking for a sci-fi book, you only have to search the sci-fi section. That's the big idea behind advanced methods like Index IVF. They pre-cluster the data into groups, which is unbelievably fast because you're only searching a tiny piece of the data. Now, you might miss the perfect match if it was miscategorized, but you'll get a fantastic one almost instantly. And that flexibility, that choice, is exactly why FAISS is so fundamental. It lets developers pick the right balance for whatever they're building. For most things, like a movie recommendation, a near-perfect answer right now is way, way better than a perfect answer that takes a minute to load. This is why it's truly the backbone of so many systems we use every single day. And all of this leaves us with one final thought to chew on. In a world with practically infinite data, where speed is everything, what really matters more? Is it finding that 1 in a billion mathematically perfect answer? Or is it finding a really, really good answer instantly? That's the core question that FAISS helps the architects of our digital world answer every single day.